Hi, I'm Josh Barron. I'm a program manager at DARPA, and I was asked to wanted to provide an overview in terms of how DARPA looks at secure multi-party computation research. Uh, so, um, so DARPA has been investing in this kind of research for a bit over 10 years at this point, and are certainly in what I would term more broadly as advanced cryptographic research. This started with the PROCEED program, where we were looking at fully homomorphic encryption and some MPC, and as a program that was more or less run at the same time called SAFER, on safe resilient communications over the internet, that actually did use three-party MPC to route communications over multiple servers. For the last 5 or so years, we just wrapped up the Brandeis program, which worked on MPC and differential privacy and focused on human factors of secure technologies or privacy preserving technologies. And I'll go a bit after in terms of kind of what the underlying tech that might be relevant for this group came out of that. We did some work on indistinguishability obfuscation on a program called SAFER that's been completed. We're currently working on a program called RACE, Resilient Anonymous Communication for Everyone, and that's based on secure distributed messaging in contested network environments, using MPC to actually create distributed resilient communications protocols. And then CIV, which is also ongoing on zero-knowledge proofs for DoD applications. We did a brief effort on privacy-preserving machine learning called cooperative secure learning. And finally, in our sister office, MTO, there is a program called Deprive, building a hardware accelerator for fully homomorphic encryption. So, that's just the overview of how DARPA has played in the space. Let me take a step back and just kind of say, well, why is DARPA funding any of this anyways? And so backing up, DARPA was founded in the late 50s. Our purpose is to prevent or cause technological surprise. And the reason that we've been involved in cryptographic technologies for so long is because we as the DoD want to keep things secure. Want to find novel ways to make applications that previously were not resilient or secure, more resilient or more secure, or keep specific kinds of information maybe always encrypted. DARPA is a funding agency, so I always like to say I don't do anything, I just pay people to do things. And so we've given hundreds of millions of dollars. We've funded hundreds of millions of dollars worth of research in this general area of advanced cryptographic technologies over the last decade. And so one of the things I guess I'll start by doing is just, again, going in more depth on the kinds of things that DARPA is doing right now. And then I'll try to finish up maybe with some more general remarks about kind of where we're seeing MPC. So we tend not to talk about it as an MPC program, but the Resilient Anonymous Communication for Everyone, or RACE program, is using MPC in a really novel way. So what we thought about 4 or so years ago is that privacy or anonymity technologies such as Tor are great in that they are distributed, and so that makes them resilient, but they have to announce where they live, and as a result, they get blocked. And so the question was, could we walk, Tor, as you know, does web browsing. Could we walk dramatically back in terms of the underlying functionalities that Tor was doing, so move from web browsing back just to messaging? And then create a still distributed system. But because it was doing less, maybe it didn't have to announce enough about itself to get actively targeted. And so the upshot from a cryptographic standpoint was, could we build 100 to 1,000 distributed backend message passing service where instead of just doing end-to-end encryption, so if Alice is sending a message to Bob, then just the message is encrypted, actually encrypting both the message and the addressee, and then having a set of distributed servers that, using MPC, figure out ways to route the message from Alice to Bob without any one, or ideally any of the servers, actually learning what message has been passed to who. And as a result, actually you get metadata security for free, right? Because the servers don't know what exactly they're doing, they can't track at a global state level what's really going on in the system. And that helps keep even fact of, how many messages is Alice sending to Bob, when is Alice sending a message to Bob, or any kind of other things like that. That's encrypted. That's actually secured by the secure multi-party computation protocol. Unfortunately, from kind of a resilience standpoint, if all we did was build a distributed MPC architecture and you tried to put that in a country that, really wanted to censor everybody, they could see in their networks like this giant distributed network and they try to block it. And so the other thing that we're adding to that is these hidden communications protocols. The upshot from an MPC standpoint, is that we're doing highly distributed secure multi-party computation over very not ideal links. So you don't get the tens to hundreds of Mbps that you want in terms of point to point. You actually get, from server to server, you get somewhere between 1 and 5 Mbps, 5 on a good day, in order to try to route things. And so that's created a very kind of novel MPC setup. And in the coming year or so, I look forward to us open sourcing more and more of these technologies so you can kind of see what we've done. In terms of, I'll kind of switch gears and talk a bit more about some of our zero knowledge work. I know we're talking more to the MPC Alliance rather than to a broader ZK group, but I'll just point out that a lot of what we're doing lately has been not just making zero knowledge faster, but making it relevant to more DoD applications. And that actually gets to the crux of some of the things that I think DARPA focuses on that maybe the rest of the world, it distinguishes what DARPA does from the rest of the world. Namely that if it has an existing reason for investment in the broader community, typically DARPA won't invest in it. So as a classic example, in the zero knowledge case, there's a lot of intersection between zero knowledge and cryptocurrency technologies. There's so much money in that space, there's not a lot of utility for DoD to do investment there. And so in the Civ program, where we're looking at zero knowledge, our actual investment has been in candidly like giant circuits. So we're focusing away from the cryptocurrency standpoint and more from other more plain or intuitive things you would say in plain English, but as a result lead to giant circuit sizes, for example. Or in some other cases where we're looking at, like, say, zero knowledge proof of computer exploitability, the representations themselves are massive. And so instead of looking at, what we often see in the zero knowledge world of the commercial zero knowledge world of millions of gates, in our program, we're looking at billions to even trillions of gates. And so that's also, by the way, why we're doing the particular kinds of zero knowledge that we're doing in that space. I want to actually talk for a second about a very recent application that we just open sourced that came out of a different program, and that's our Brandeis program, which had already ended. We just open sourced a software called Coffee Break, where it uses MPC purely on mobile phones in order to have multiple acquaintances, up to 10 acquaintances, use true garbled circuit work to find a noisy meeting point. When I say noisy, it's because if it calculated the exact meeting point, then you could probably infer kind of where different people are. So actually, as one of the inputs, you don't actually put in your exact location, you put in a noisy location, therefore it finds a noisy middle point. But the upshot here is that well, again, from a capability standpoint, what we're doing is we're letting people who may not know each other find a way to meet up in a more like direct data. Instead of saying, oh, I'll meet you on like the west side of Washington, D.C., you can actually input some more accurate information about yourself without the other person finding it. But then from a tech standpoint, this is MPC on mobile devices, on Android phones. So, just taking a step back, I started this talk by talking about how we were doing fully homomorphic encryption, in the Proceed program, that, reduced the asymptotic complexity of FHE from like 10 to the 14 to 10 to the 7th per expensive operation. And here we are 10 years later, actually just doing, it inverts the process. Fully homomorphic encryption was very much in this kind of client uploads to server does all the hard work. And now in the Coffee Break model, the phones, which are, ostensibly lower, less expensive, lower capability devices, they're doing all the computation. And now we're just using the cloud as your comms channel. And what's good about that, among other things, is that your data kind of stays on your device. And if you send it off, it's always encrypted. And so the cloud really doesn't have to see anything. So it's really kind of a different time. Talking about how Well, I can't, one of the things I kind of say here is that I'm a program manager at DARPA. I can speak for myself. I would never say that I speak for DARPA. So what you're going to get is my opinions on what I am seeing in terms of funding and capabilities in the secure multi-party computation space. And this comes now out of working for the last 5 years to try to take DARPA-funded technology and transition it, which really means go to industry, go to government and say, hey, here's this cool stuff that we paid for. What do you find interesting? So I thought I'd talk for the about 4.5 minutes I have left on what I have seen. So one of the things that I probably want to foot stomp the hardest is that, well, one, it's not about the complexity of the MPC solution. In fact, if we're going to transition something to the real world, very often it's by far the least complicated thing. If an end user comes in and says, we want you to do this thing, if the cryptography is particularly complicated, that already is a leg down, or not, the opposite of a leg up, I suppose. But that already is a negative, because really when you talk about real world applications, the vast majority of the time, the hard work isn't the cryptography itself. It's the integration of the technology into the broader system. And it's the legal and policy requirements to actually get that technology over the hurdle. So in other words, it's not so much about can you have 3-party MPC or 2-party MPC, it's do the lawyers, the compliance, the policy people, are they okay with distributing data across 3 nodes? And are they willing to accept the fact that, that once we do that kind of distribution, it really is from a legal or a policy standpoint distributed? And so, there's a lot of pioneering work done by, for example, Boston University, looking at the Boston Women's Workforce Council. There, they did 2-party MPC, looking at wage disparity between men and women, and they got a bunch of companies to kind of upload their salary data. I should mention, by the way, this is not DARPA funded. This is NSF funded, but I still think it's super cool. The BU people would be the first to tell you that the crypto is trivial, essentially. The hard part was actually getting everybody to use it. And so much of what we're seeing about cryptographic technologies is less about the cryptographic technologies themselves and more about the communications about and the discussions arising around kind of the deployment of those cryptographic technologies. So that's thing one. Thing two is that, I think if we talked 10 years ago, there was this, God mode vision of cryptography where I could take the most sensitive data and then run it in, the open cloud because it's encrypted, because it's secure. And again, just going back to the point I previously made about regulators or kind of policy people, it turns out that makes them run for the hills. And so what we have found our best success is finding data that you want to have encrypted because it is for some intuitive notion sensitive, but it's actually not covered by regulation because, for example, say in in the DoD side, you see classified to unclassified or whatever it is, that there are regulations that go towards that. And it would be a lot easier if you don't have to actually contend, for especially those initial applications, if you don't actually have to contend with the very people who regulate what's allowed to be done in that space, but rather you have a more free space to innovate technically, and therefore kind of don't have to deal with some of those things. So, for example, doing things in the health domain, we have historically found rather difficult, whereas we've seen, for example, in this personal location stuff, which again intuitively is quite sensitive. There's no, at least this stage in this country, regulations around that. A related idea that we have found in that space is, we've heard from folks in the world, though we have done kind of less in this space, is that in some cases, if you can find them, there are some times where different entities are actually required to share data with each other or strongly incentivized to share data with each other. And yet have restrictions on sharing it or other places like that. There was one state that we were made aware of that, for example, required all data related to kind of juvenile outcomes to be co-located, so the whole state could see how the different between the health services, the schools, and the kind of the criminal system, they wanted to see, for the same kind of juveniles, like how they were treated across, and yet you couldn't actually co-locate those data. And so that's a place where MPC really can be quite powerful. The flip of that, specifically in this one case, was that the state still didn't find a way to actually make people talk with each other. And so we actually couldn't come up with a good application in that domain. Finally, one of the things I guess I'll say, and just to wrap up, I'm actually a little bit over my 15 minutes as I see this, is what we have found is that, especially for secure multi-party computation, blockchain technologies are a bit of a net positive. And so let me take a step back and actually kind of do a full view of the world. There are basically kind of three classes of secure multi-party computation that we're seeing, or at least variants or kind of similar flavors of. In the two-server model, we're seeing a lot of things like Prio. If folks are familiar with that, where you just want to do very standard 2 out of 2 MPC, but for a variety of reasons, it's very feasible to stand up those two servers. Things are very, very efficient, and we've seen a whole class of activities in that domain. We see a little bit in kind of broader secure MPC. That could be 3 or kind of a collection. Typically under 10 or so, could be more. Again, our race program, which we talked about, is hundreds, which could be very, very high. But again, in most real world applications, we're seeing like 10 or so. And then what we're seeing is a lot. And a lot is in, like, say, the blockchain domain, where you're talking about either permissionless or permissioned, but kind of at some scale applications. And it's in this last one that I actually think MPC has a role to play. Because one of the things that we're seeing is that, and again, this will get a little technical, and I apologize if so, but people are using blockchain when they really want threshold cryptography, which is to say, what they're mainly distributing is the ability to do encryption or other things like that. And there are places where this kind of a more, threshold cryptography, which I personally would think of as a more kind of simplistic form of secure multi-party computation, has a role to play that doesn't, for example, build a giant blockchain that gets ever more large. Because all you really had to do in the first place was just kind of distribute your underlying root of trust in the cryptographic process itself, which threshold cryptography has been able to do for decades. And likewise, we're seeing certain aspects of kind of certain private computations that you want to be able to do on top of public blockchains. So what I do think as blockchain technology continues to take off or expand, and certainly as people get to be more sophisticated in their views of how to use those kinds of technologies, I do think MPC has a role. And so with that, I thank you all for your time, and thanks for giving me the opportunity to speak today. Thank you.